go? There we go. All right. So what I'm doing right this second is, in your Google Classroom, I'm uploading the blank slope field worksheet, just in case you lose it between now and tomorrow, and the worksheet answer key. So uploading and posting as an announcement. Let me go ahead and not just do it in your period, but also hopefully period 6. Oh, hi, computer. You guys should have been in a teacher's meeting this morning. Had to do with technology, let's just say. Here we go. Ba-doop, ba-doop. There we go. And let's post. So, reminder, slope field worksheet due tomorrow, turned in tomorrow morning by 7:55 a.m. As I said, once again, it's due by the end of the day, but technically giving grace through tomorrow. Oh, hi, computer, still not working. Awesome. Let me try to refresh. Nope, that's going to lose everything I just did. Let's do show. Maybe that's it. Nope, it's still posting. Oh, nope, it's there. I don't know what's going on. Okay. So here is the answer key. It is officially in your Google Classroom. You guys can check if you did the flows right, if you did the matching right. Ooh, if you did the follow the flow and the solving for the tangent line and using the tangent line, the long answer, and a few more matching. Okay. So that is online. You guys could be peeking at it if you are bored right now. What we're doing right this second is actually going back to homework from yesterday, the one that I breezed through the evens and told you guys to check out on the YouTube video if you wanted to look at it a little bit longer, because obviously you did not have a lot of time with chapel, although chapel was well worth us being out of class early. So is there anything you guys need to look at in homework? Section 5.1, the book. Slope fields, the book work. Anything that we need to go over? Odds or evens? Vico? 92? Kathleen, what else? 30, 30. Okay, anything else besides 30 and 92? Okay, so let's start with number 30 and then going to number 92. Number 30 was down here in the section that said verify and then find a particular solution. So with this one, let me get this really quickly over here. Oh, come on, computer. You can do it. Put a little power to it. Come on. Open the snipping tool. Open the snipping tool. Open the snipping tool. I think we should hire a computer whisperer. Open the snipping tool. Okay, let's try over here instead. There's the snipping tool. All right. If they say verify, what does that mean they've actually given you? The real thing. So they've given you the solution. Now, guys, which of these is the solution and which of these is the differential equation? Which one's which? Come on, we worked on vocab a lot. So yeah, the solution is the one without the prime. That would be this one right here, and it has a C. That should make sense in your head at least a little bit. And so who is this guy, Kyle, the one with the prime? He's the diffie-q, right? We can even spell it like the cool college kids do. Okay, so as a diffie-q, he has the dy dx in him. Now here's the really, really good part. They're not making us go this direction. They're not making us do the dy dx and multiply the dx and then take an integral of both sides. They're just saying this is the solution. What's the word up here? What's the word up here? Verify. Okay, now how do I'm going to plug in, right? 3x plus 2, we always plug in, right? But to plug in, don't I need to know the derivative? Okay, so let's review. How do I take derivatives implicitly of functions? Close. dy dx is a noun. ddx is the verb. Does that make sense? Okay, so we're going to derive both sides. And if we derive the whole shebang, I'll just put brackets around the whole thing, wouldn't I get 6x plus, wait a minute, why can't I just start writing this? What happens in the next term? I do get 6x, but what's next? Okay, derive the y's. Times, do you remember? dy dx, good. Equals, okay, what am I supposed to be plugging in here? Who is this guy again? dy dx. So who do I need to get by himself? Yeah. So let's subtract that 6x. Let's divide that 4y. That's what I need to plug in for my derivative. Remember implicit differentiation? It's been a while. Now, what's reproduces, right? 2 times 6 is 12. 12 over 4 is 3, so I have negative 3x. Hey, have I just verified? Awesome. Now, it says verify. I've done that. And then it says, why am I going to take all the time to come over here and, even with my bad orientation, to pick a blue pen?
You're underlining.
But why blue?
Clue.
Don't I have a 1, 3 that I can go plugging in to figure out my C? That's a bad combo, but that's okay. Now this is the answer. Remember, this is from my book. When the answer is shown, this is actually like pink or something. All I need to do is plug in. So 3 times 1 squared plus 2 times 3 squared equals C. Isn't that just 3 plus 18? What's C equal? 21. What's my final answer? The equation with the C plugged in, right? Dun, 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 dun.
Done.
Are we okay?
Yeah.
Everything good?
Wow.
What was the confusing part? Can you verbalize it if you recognize it?
I just didn't know how to solve it because I didn't know.
The dy dx kind of thing?
Yeah. I was like thinking I probably had to do implicit differentiation, but I also didn't know what the question was asking.
Does it make sense now how we broke it down though?
Yeah.
So the first thing I did is, verify the solution. Who's the, that's the solution. Oh, that's a differential equation. Oh, verify that works for that. Plug it in. Yeah, keep an eye on that vocab. Let's see. And remember, if we're finding a particular solution, if they give us the general, just plug in that clue. Just plug in that clue. Now, Rico, yours is number 92. Is that one of those multiple choicey ones? Yeah, it is. Oh, it's a free response one. Even better. Free response. Isn't that kind of what we practiced yesterday in class, guys? Didn't we do like a longerish one? And how many of those longerish ones are in that packet? The homework one? No, the homework one. Isn't there literally just one? Am I crazy? I mean, that might still be true, but isn't there just one? I thought it was just number 18. Hi, my ones that usually interact and are not interacting at all. Okay, those are not FRQs. Those are not free responses. These could be like a part A to a free response to sketch, but those are just sketching. These are just matching. These are just matching. Oh, this one, you have to follow the flow, but that's not really a free response. Okay, kind of in part C. But there's only one. There's only one. I'm not saying he's easy, but there's only one. And then matching. Okay, so then coming back, this could be good practice for that one. We have a differential equation. He's right here. Consider the differential equation. Oh, why, thank you. You told me what it was, even though I should already know. Ooh, let's not use blue. Let's use red unless we're dealing with the clue. Okay, differential equation. Here he is. Boop, boop. Let y equal the particular solution of the differential equation with the initial condition. Why am I now getting a blue pen?
Because we have a clue.
We have a clue right here. Isn't the clue 0, 1? You guys know who's x and who's y, right? F of just making sure you're good.
Oh.
F of x. The function f is defined for all real numbers. Okay, a portion of the slope field is shown below. Sketch the solution curve. Hey! You're good. I was just checking on you. Follow the flow, yeah? Is anybody confused by the flow? Well, wait a minute. Hold on. I think it's sideways, right?
Yeah.
And then you kind of do like a downish thing, and then
Go back up.
you do like a back upish thing, and then like a. I see like a down and upish, don't you? Kind of.
I just made mine more steep.
Yeah, maybe more steep. I think you're right with going more steep. I probably should have.
I definitely did like an up again.
Oh, how far up? Like up?
Yeah, because I saw the leveling off of like the top, so I thought, I don't know. That's what I thought. Because the slope equaling 0, I thought that was like the leveling.
But see, weird though, because it had to come back down, yeah.
Yeah. So I don't know. Whack.
No, it's okay. I see. Because you were trying to like get up there, but sometimes remember, like if you put your finger inside of Saudi Arabia or in Iran, like it could be separate.
It might just be that it's like.
Yeah. portion of the slope field of the differential equation. Sketch the solution, got it. But what's part B say? Hey, this is a lot like number 17 in your packet. You can go look at number 17 in your packet if you want. Isn't number 17 in your packet, part A and part B tell you to follow the flow, and then part C say something about a tangent line? Could you maybe be doing number 17 in your packet if you haven't yet, as we do this one in the homework? Just trying to help. Come on, guys. Be quicker on the uptake. Okay. So, it says, write the equation of the tangent line. How do I do an equation of a tangent line from my forever card? Y minus y1 equals times. Okay, figure out what you can plug in. At the point pi 1. Oh, sweet. Pi goes in the x spot, right? 1 goes in the y spot. You check in 17C and see if you know how to do it. But this one, I also need a derivative. Hold on, where does the slope of the tangent line come from? The differential equation. Slopes. So can't we come up here and can't we figure out who dy dx is at the point pi 1? You guys doing it for 17C for that differential equation and that one? Plug it in, I get 4 minus the y value times cosine of the x value. Now this is an FRQ. Could you technically just keep this and plug it in? Yes, I suppose. But what does it tell me in the next step I'm supposed to do? Use it to approximate. Hey guys, is this, well, hold on. What is 3.2? Is 3.2 an x or a y? So aren't I trying to figure out or approximate f of x at x equals 3.2? And isn't f of x just a y value? Check it. Don't I have a y in my equation? And don't I have an x in my equation? If we just break it down and say, hey, that's your x, can't we just go ahead and plug it in, plug it in? Plug it in, plug it in. Solve, solve, solve. And then put that as the approximate of f of 3.2 because the y value of the tangent line is the approximate of the y value of the function. And this is how you could totally stick it to the man and be like, But if you want to match it in the back of the book, we should probably do 4 minus 1 is 3. Cosine of pi is something that we should know. Cosine curve of pi is negative 1. And then I have a yucky 3.2 minus pi, which I don't honestly know. We could pretend like we do, though. That ends up being negative 3 times 3.2 minus pi plus 1. The approximate of f of 3.2. You guys using this to help you out with number 17C? And that's one of the 2 long answer ones. 17C on the packet, super similar. Nico, we good? Remember, a tangent line can always approximate function values. Maybe not super well, but it can. And 3.2 is really close to 3.1415926. So the y value of the tangent line can be used to approximate a function value at a particular x. Good question, and that should have helped your classmates out, and hopefully you as well, on number 17. All right, guys, those were the bookwork ones. Let me get out of that and let me get back into your Google Classroom. Is there something else that you guys want to talk about on the packet really quickly? Because we're not taking class time for it. Maybe you haven't graded it. Maybe I will take like a last minute something or others in class, but you guys need to have turned it in already. We could just talk about it a little bit more if needed using the answer key. But for right now, is there any place that you've gotten stuck? Yeah. 18B. Ooh, nice. You guys can benefit from this. Now, careful. If this is the only long answer in the packet, and if 2 of your classmates have already gotten stuck, is it kind of a bummer if you just write down the answer right now? Yeah. Okay. So I might not do it fully, but let me at least show you the direction to go. Does that sound good? But let me just give 30 seconds for anyone who has not done this yet to read the information thus far. Consider the differential equation. You can read part A, and you can look at part B. As some people are reading through part B, what I need all of you to realize is something that I told you yesterday specifically to help you on this question. I said sometimes differential equations, especially the diagonal ones, are impossible to solve by hand, meaning impossible to anti-derive. I wrote it in yellow. I showed you in the notes packet. Anytime we have plus or minus. So right away, before you guys even tackle this FRQ, your brain, maybe not right this second because we're still kind of getting used to these guys, but I hope by the AP would look at this and would be like, hey, I cannot integrate this. Which might help you at least know what not to do for part B. Because part B says this is a solution. But wait a minute, how do we find solutions? This isn't saying sketch. Following the flow is part A. What do we normally do to find solutions? How did we find solutions yesterday? But if this says solution, and if we can't integrate, must we be doing something else? So pause. Isn't this one of these where they've actually told me a solution for? How do we verify, or how do we try to show that it works if we can't go from here to here? If we can't integrate, if it's impossible, and I was telling you the truth, please just have a little faith. If it's impossible to integrate in section 5.3, we'll see why. If it's impossible to integrate, what must be the direction that we're going? Yeah. It's not integrating, but deriving. If this is a solution, then question, shouldn't I be able to find his y prime and have it match? Okay, well what is his y prime if b is a constant? 2. What does 2 need to be equal to? 2y minus 4x. If this truly is a solution, then his derivative must equal dy dx somewhere. His derivative must equal dy dx somewhere. Now, where will that somewhere be? Some of you might get stuck when you see this, but others of you might be like, no, let's get y by itself. What happens if we get y by itself? We did this the other day when it mentioned vertical tangent lines, and so we set the denominator of the derivative, the differential equation, equal to 0, and we got what y equals in terms of x. Y would equal? Add the 4x, divide by 2, which would be 2x plus 1.
Okay, I have a question.
Pause. But did everybody follow the math I just did before I answer Adam's question? I just got y by itself. And where did this come from? I said, your derivative better equal u or else you won't be a solution. So I found his prime and I said, okay, you guys have to be the same. I solved for y and then I'm going to, Adam, what's your question?
So I got the same thing, but instead it was like, since I did like an mx plus b, I just looked at kind of like the y-intercept and picked the positive one.
What y-intercept though?
The positive one.
What y-intercept though?
Well, because it said it passes through the point 0, 1.
It doesn't say this one does.
Oh, so it was just like a lucky, like...
Two separate, yeah, it was a lucky guess.
Okay.
Unless you were looking at your slope field and you realize all of these are curved, maybe curved, maybe curved, maybe curved. The only one that the line seems to go through, 0, 1. But we can't actually use the slope field itself to prove much besides a flow.
Okay.
Because remember, we're only taking little fragments, and so there's a little snapshots, and if we zoom in, who knows what was actually going on? Do you know what I mean?
Yeah.
So it was a lucky guess. Unless you looked here and you were like, ooh, it's a line. It was a lucky guess. So justification. Since the dy dx of the solution must match the, probably don't put OG on the AP, differential equation, B must be 1. Right? All we did is say, well, hey, if it's a solution, then his derivative has to equal the differential equation, or he has to work inside the differential equation. So all I had to do was get y by itself and say, what is y? Because that's what this is saying. What is y for this solution? Well, y must be 2x plus 1. B equals 1. Okay, I went ahead and kept on doing that one because that was a weird question. Let me see if I can give a little less information. C says, let G be the function that satisfies. Ooh, they give me a name but not a function? Gnarly. G of 0 is equal to 0. Okay, I mean, 0, 0 is the point. It appears from the slope field. Here we go, Adam, ready? It appears from the slope field. Is that enough to justify? No. It appears from the slope field G has a local max at 0, 0. If you were to graph 0, 0, does it appear, does the flow seem to have a max there? Yeah, maybe. But it says, using the differential equation, prove that this is so. Prove that this is so. So they've told me, hey, 0, 0. They've told me to prove 0, 0. I'm not going to do this one all the way. I know the answer key has more information. They're saying, seems to have a max. But this appears is not a proof. So here's my hint. The only way to use an act, the only way to use an act to prove a local max is with the second derivative test for relative extrema. If I was to do the first derivative test, I would need to do a sign chart, and I would need to go a little bit before and a little bit after as determined by the critical numbers. The problem is they have not told me all the different critical numbers. And if I was to go up to the top, critical numbers, remember, are when the derivative is equal to 0, and those are possible relative extrema. I have 2y minus 4x is 0, 0 a critical number. Yes, 0, 0 is a crit of g of x since dy dx at that 0, 0 equals 0. I have a crit at 0, 0. But I don't know any of the other crits because there are infinitely many different places where I could have a 0. It's just anytime y is equal to, we already figured it, 2x plus 1. We could plug in tons of different x's and get tons of different y's, and all of those are going to have zeros. So I'm not going to make a sign chart. I'm not going to make a sign chart. Instead, since I can't go just directly before and directly after plugging and chugging, instead I have to use, you must use the second derivative test for relative extrema, which says you need to know a crit, check, and you need to know its second derivative sign. Because what does second derivative sign, positive or negative, tell me? CalcAB. If I know I have a crit and if I know it's concave down, or if I know I have a crit and it's concave up, I can tell whether there's a local max or a local min, aka a relative min or a relative max. But wait a minute, guys. I mean, you can look at this and say, I think it's concave down. How do you prove it's concave down? Derive the derivative. Didn't we practice finding d squared y over dx squared yesterday? Derive the differential equation and then plug it in, and prove to me that the second derivative is negative, which means the function is concave down, which means since there's a critical number at 0, 0, it is a local max. I just gave you the proof. You guys just have to take the derivative and then finish it off. All right, cool kids, let's get back to section 5.2. Let's get back to section 5.2. As you guys finish attempting that packet and as you grade it, you are going to be turning it into the tray that's only what's there for period 1 and for period 6 because it's due before school tomorrow. But you may make a quick little note in your composition book or your homework spiral of certain ones you want to look at in the answer key tomorrow if you're not fully sure why. Does that make sense? Now pause. We had to do this in our integration as net change packet. You were supposed to attempt it and grade it. Guys, I have to hold you accountable to what I'm asking you to do. It doesn't make sense for a teacher to tell you to do an assignment and then not really grade it on what they've asked of you, right? Called rubrics in English. So here's the dilemma. The integration is net change packet. Did I have some people that had absolutely no color pen marking on their paper? What does that tell me? Either one, they didn't grade, and they BS'd it. Or number two, they did it with the answer key, right? Either way is bad. Now I'm not taking off what I should, which is like 50%. I'm not even taking off 20%. I only took off 10%. But I'm warning you this time. What do I need? What do the TAs need to see in the packet to give you a credit? Yeah. Grade it. Now is it a little sketch of everything, single thing is a check mark? Yes. But are there lots of weird ones in the packet? No. There's only one long answer. Do the best you can. We went over part B and C. So maybe you do get 100% on it all. Maybe you miss a multiple choice here or there, but I need to see the color pen graded. Okay? Remember, don't I set up my entire class that we're supposed to be learning from our mistakes, so it's okay to make mistakes? You don't need to have perfection on this packet. I don't want to see perfection. If you got 100%, that's great. Show me the color pen that you're going through and marking and doing check marks along the way. But if you make mistakes, pause, get out a colored pen, and show it. And then maybe try it on by yourself again. Maybe try to rethink or go one step with the answer key and put the answer key again away and check it and then grade it again. Or if worse comes to very worse, you can write the correct answer in the colored pen, telling your brain when you get it back and you're studying it later, you didn't know how to do this. Do you understand it now? Alright, here we go. So, we have two little blanks down here that we need to fill in. And then we have some examples to play with. I also have your section 5.2 homework open. So I think I have some numbers in here that are like from old packets, but similar ideas of, or old book sections, but similar ideas of what you guys are going to be facing. Let me get rid of these couple lines. And I'm going to actually move these down a little bit so that we can take those two full lines of space. Okay. Do you guys see that both of these, this part 1 and this part 2, both of them are two differential equations? Do you guys agree with that? Except it's not dy dx. What have I shown you as far as the independent variable? It's dy dt. So time is my independent variable, like x. Yeah. If I was supposed to be solving, check it, when solved, there's no plus or minus, which means I should be able to solve it. I'm going to solve one of them, and I'm going to show you by similar logic, that AP wording, by similar logic what this one does. But first of all, okay, if I was to solve this, I would need to multiply that dt to the other side. But guys, as soon as I multiply that dt to the other side, do I want that y there? Because this is only in terms of t. The k can stay. I don't care about him. He's a constant. But what am I going to have to do that with that y when I multiply the dt on the other side? Which side says, give me your y's, give me your tired, your poor, your one? Liberty. I don't have that memorized very well. Move it to the other side. Right? Oh, yeah. I have to move it to the side where it says, I can do y's. That's not the dt side. The reason I need to split up those differentials is to get my bearings. Ooh, vectors. We're going back there? No. I need to move my dt and say, okay, I don't mind constants or things in terms of t. But I do mind y's. Get the y over there. Oh, that's legal. It's legal to do what? Integrate. Okay. So what happens if I throw an integral on both sides? Remember, the point of this section is not learning how to do any differential equation. That's 5.3. This one is, there's a special differential equation, and it's these two guys, but they're really kind of just one. If I take the integral of 1 over u du, don't I get ln of u? ln of y plus c, sure, but we can move him to the other side to go with this kt plus c. However, like we saw yesterday with that weird plus or minus square root thing that tracked the c, sometimes when I take antiderivatives of harder differential equations, I'm going to have stuff on both sides. Think kind of like an implicit function or implicitly defined solution. So if I did want to get y by itself, just check it. Isn't there a y of t over here? If I did want to get y by itself, what would I have to undo? And how do I undo ln? E. This isn't calculus, this is just pre-cal. Undoing the ln, I have to do e to the power of, please put parentheses, e to the power of both sides. Now I get an absolute value of y is equal to, now here's where it gets a little crazy and we have to review properties of exponents. If I have something like x to the a plus b, doesn't that come from that addition of exponents? Didn't that come from multiplication of like bases? Don't you add the exponents when you multiply?
Yes.
Right? By similar logic, ooh, we're doing that too. I can say e to the kt plus c is e to the kt times e to the c. Isn't e a constant? Isn't c a constant? What's a constant to a constant? A constant. Ready? C e to the k t, exponential growth. C e to the k t. Do you see it over here? No, there's no c. I know, but there's a y sub naught. Oh, it's kind of like motion. The plus c was the initial amount. Exponential growth and decay. Exponential growth and decay. My y of t, well actually, yeah, we'll label it. My y of t is my amount, we're used to that, after time t. My y sub naught is my initial amount, or initial population. And my k is kind of like the constant of proportionality, which you guys have seen in things like direct and inverse proportions. Proportionality. Oh no! It's way too long. Proportionality. Kind of like the rate.
What is k?
T is the constant of proportionality because at the very beginning, the differential equation is special because the rate, aka the y prime, is directly proportional to y. Or the rate is directly proportional, well, with a positive or with a negative. A positive directly proportional rate means increasing rate, aka growing. And then a negative direct proportionality is a negative rate, aka a decreasing amount, aka decay. So by similar logic, I can also technically say if I did the exact same thing with this guy, what I would end up with would be my y of t is equal to, well, I guess we'll leave that snazzy language over there. Absolute value of y is equal to c e to the negative kt. Positive k shows positive growth, well, shows growth. Negative k indicates negative growth or decay.
Whoa.
So this is where this exponential growth equation comes from. Now there is like a hint. There is a hint for the sciences. It's not going to necessarily be that helpful with the AP because they don't really talk about doubling or half-life, I don't think, on the AP that I've seen. Doubling and half-life. Is that we can actually rearrange these equations just a little bit and we can say, okay, we can also talk about the ratio of what you have to what you had. Depends on whether you're growing or decaying as to whether you're going to think of it as a positive KT or a negative KT. But we can also just rearrange it a little bit by dividing by the initial. And so doubling, I can actually set that ratio, what I have to what I had, equal to 2. And say, well, if I started with 5, I have 10. If I started with 50, I have 100. If I started with 250, I now have 500. It's like, whatever, the ratio is 2. And I can set 2 equal to e to the kt. And if I was doing half-life, I could set that ratio equal to 1/2 equal to e to the negative kt. And if you guys remember your log properties, let's do green. we can actually solve for. My chemistry people, it's about to get exciting. We can actually solve for something in chem that you guys normally just memorize with doubling and half-life. Because we could mathematically. Oh, did I just move that in kind of weird ways? I did. The equals is supposed to be somewhere else. That's okay. We can end up with KT is equal to ln of 2, or negative KT is equal to ln of 1/2. Yeah, because ln of 2 and then ln of 1/2. According to pre-cal, I can see 1/2 as technically being ln of 2 to the negative 1. I can bring that negative 1 in front and then move it to the other side. Either way, I get KT is equal to ln of 2. And then depending on what you're solving for, whether it's the rate or whether it's the time to double, I could go ahead and figure out the time to double is going to be ln of 2 over k, or I could say the rate is going to be ln of 2 over the time to double. I could solve either way. And to be honest, I could do that with growth or decay. So there are some relationships with doubling and half-life that truly just come back to rearranging mathematically, playing with this exponential growth and decay equation.
So they're the same thing. That's whack.
Yeah. They're ultimately the same thing.
Don't know how I feel about that.
But it's going to change a little bit because time to, well, the k will be positive or the k will be negative in the original equation, right?
Yes.
So, and that way I have a positive or a negative k. But you could technically just memorize the relationship between t and k with ln of 2 for doubling and half-life both. Coming back here, I could go ahead and play around with some differential equations, but to be totally honest, I think that's technically, is that where your homework starts? It does a bit. Word problems are coming. The nice thing is we still have all day tomorrow. Let's save the word problems for tomorrow. Let's play for right now just with a couple different equations. And I think I'm going to go ahead and play with just these two. Okay. Because your homework technically doesn't start with like p's and y's and t's. It starts with good old-fashioned dy dx. And good old-fashioned dy dx, kiddos, what did I say you're supposed to start with if you're supposed to solve, which integrates maybe doing some sort of integral thing? What do we first do? To get to an integral,
Get to the thing.
I need the dx over here. And as soon as the dx gets over here, who cannot stay before? Yeah, okay, so wait a minute. I'm not going to be able to add or subtract the y because it's grouped together as soon as I multiply. But what can I do? I can divide. You see it?
Mine's Tokyo.
Now this one's kind of boring, so it's just going to be an x on that side with a plus c. But over here, why am I going to put a negative ln of 4 minus y?
Because it's going to be set by the negative 1, we're going
Nope.
to need 1 power.
But good idea.
I don't know, man. Why would you do that?
Why did I do that?
Oh, is it like
Remember, so you see in VC we do U sub mental math style. U sub mental math style, what should you guys have done?
it's negative y?
It's not ln unless you think about 1 over u, and you can't think about 1 over u if you don't at least ponder the du. And the du is going to have a negative that needs to move before you get your negative 1 over u du that you can go to ln of u. Plus c, but he went over there. Now can I move the negative over there? Sure. I have ln of 4 minus y is equal to negative x and minus c, which is still an arbitrary c. I can throw in my, hey, it's pre-cal time. Let's get rid of the ln. I get e and I get e. What did we see we can do if we have e to the power of c? I can move that c in front, e to the negative x.
So is that for always? Like it always will?
Whenever I have an exponent addition.
Okay.
If it was a subtraction, I could make a division if I really wanted to. 4 minus y, I can add the y, I can subtract, and I end up with y is equal to 4 minus c e to the negative x. If you want to make it c over e to the x, totally fine as well. Technically, I have absolute value, which makes it a little more interesting. I forgot that.
Yeah,
But remember absolute value equations, what they do in algebra, I know it's been a while, is they either make it a positive C or they make it a negative C. Absolute value equations, the way you get rid of an absolute value is to say, hey, you're a piecewise function, sometimes you're positive and sometimes you're negative. What do you notice about a plus or a minus multiplied by a C?
It's still C.
Still C. Just the C might change. The C might change. Alright, kids. Doesn't give you a lot to start homework, but it does literally get you through the first problem, maybe the second one, if you can change directly proportional words into equations. But what's your main objective tonight? Alright, see you guys. Yeah, I would do the packet and starting homework. That way you have a feel for what you're trying to figure out in examples tomorrow. Ah, and there's a slope field in homework? Look at that. But tomorrow we'll be like, how do you do this kind of weird guy?